Hello. Today we have minimum cost to reach destination in time. 1928, minimum cost to reach destination in time. There is a country of cities numbered from 0 to n-1, where all cities are connected by bidirectional roads. Okay, so the roads are represented as to the integer edges. Not the road city takes time, minutes to travel. There may be multiple roads, so it's how time is. The roads represent the integer array edges, where edges denote the road between city X and X that takes time I. Okay. So, okay, 0, 1, 10. Okay, now I understand, got it. So time is the third parameter, okay. And there may be multiple roads of different travel times connecting the same two cities, but no roads connected a city to itself. Okay. Each time you pass through a city, you must pay passing fees. There is representing the necessary passing fee of lands and where passing fee. Okay, so this is like where we can get n. And I'll do this right now. Okay, so amount of dollars you may pay for passing through the city J. Okay, so each time you pass through the city, this represents a zero-indexed integer array passing of len n, where passing fees is the amount of dollars you must pay when you pass through the city J. In the beginning of you're in city 0. Okay, so we're starting from 0 and the city n-1 max time, and want to reach city n-1 in max time minutes or less. The cost of the journey is summation of passing fee for each city that you pass through the some moment journey, including source and destination cities. Okay. Given max time, edges, and passing fee returns the minimum cost to complete your journey, or -1 if you cannot complete it within max minute times, or -1 if we cannot complete it. Okay. So we have example, we have 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5 nodes. This is a passing fee for them. This is a connection time for them. Okay. Output 11. You took pack 0, 1, 2, 5. It takes 30 minutes, and 0, 1, 2, 5, and 11 worth of passing fee. So output 11. Minimum cost. Okay, so yeah. Constraints. Penalty to the edges between two nodes. The graph does not contain self-loops. All right, so this is Dijkstra. So it could be solved with dynamic programming or Dijkstra. Let's do Dijkstra then. And so Dijkstra will have first we will have to create adjacency lists because we need it for iteration. Right? And then we have to create queue, and we will keep in this queue, we will keep nodes and their cost and their time. So we have to keep 3 parameters into queue. So we have to return minimal cost. So it will be cost. It will be because we will be min-q, cost, actual node, and we have to track time as well. All right. What we're gonna do, we're gonna create adjacency matrix. We're gonna create Q with a start as we put our current node 0, and then our yeah, so we have, let's call it P. So we have a phi 0. No, first is a cost. Then we create a 0 node, and time will be. Oh, we need also. So adjacency list. Second, we will create time, probably hash time. Yeah, so it's like dictionary hash, and put all time in a hash. So we call it time, and we add time for 0. So our iteration will be as follows. We will repeating sequence will be while q. So q is a minimal q. While q is not empty, if we get all this data from q. So we're gonna have heap pop. I said q. It will be heap. And it's pretty much the same. Minimal q or minimal heap. Is it the same? Yeah, I should Google. Q and heap are q and heap is the same. Okay, and then what we're gonna do, we're gonna heap pop, and then we're gonna check first if we are on no, if time is more, we have max time, right? If time is more than max time, we just we continue. Then if a node equal n-1, we have reached our destination, we return cost. Then for every adjusted node, edge node in, so adjacency list, let's call it like graph in GI. So we have our in-G node. So we go through every connected node into graph. We push into push. we push what we have. We have a node, right? What we have to push cost. So we push fee for this node. Then wait, do we have to push fee plus current node? We have to add like this, right? Because this is our new. So it's like the extra relaxation. So it's the extra relaxation part. Yep. And we hit push node. Next is node, right? And this is time. So time will be also time plus what is our time for this node, which is let's call this times hash, times hash, and plus times, and we have a node. And then at the end, we return -1 because we haven't found anything. This is our exit point. Oh, this is our exit, right? Okay, then let's go and implement it. Looks good. So what we're gonna do, we're gonna create adjacency matrix. For 0, we have 1, 3. And with times for 0 is 5. And for 1 is 1. So we iterate through all edges and we create adjacency list. Then we add to adjacency list initiated with this, which is cost node time. And our heap, we create heap with cost node time. So cost will be always so heap will be calculated by cost all the time. And then we will we add it to queue. We pop it with if time is more than max time, no. And node is our final node, no. Then we, for every adjacent node, so adjacent node is G node. In G node, we push cost first for this node, actual node, and times. So for this, we push 1 and 3 with, and we go into cycle again. Then we pop 3 or 1, depending on which cost is better. I think cost 3 is better. No, cost 1 is better. So we pop 1, right? And then we have connection to 2 which is 2. This is 20. So we pop 2 again, and we got 3. And this is our node 5, and we return all stuff that we calculated on the way. Okay, this should work. Let's implement it. So first let's copy this. I like it. So first we create adjacency matrix, right? And for creating adjacency matrix, we create G of zeros multiplied by n, right? And then, no, it's not zeros multiplied by n, it's like default list. Okay, let's do default dictionary of list, right? Then for E in edges, what we're gonna do, we're gonna G E edges. So we have a 3 here, right? We have 0 will be connection node. G0 we will append what? We will append connection between one, because we have bidirectional. So bidirectional, it's called, let's name it bidirectional. Is it called? No, it's B. Bidirectional adjacency list. Okay, and we created adjacency list. Do we have to put time hash? So third is a time. So let's create times and default dictionary int. And what we're gonna put in times, we're gonna put subvalue times. This is bypassing time for node, right? So question is, if we have okay, so bypassing time means, okay, okay, so edges y has a 3 element, x, y, z. That between x and y take time n. Bidirectional roads representing. Okay, so can I say that E 0 time equal E2 like this. Yeah, I think so. If I understand this correctly. And then in Q we create Q, which is we put here following. Yep, this guy. So we will start from the 0, 0 with phi 0 and time 0, right? Times 0. Okay. Then this is the same our thing. We do while. We return -1 at the end. Here we push. Yeah. The only thing that we have to keep visited somehow. Because we're gonna go from 0 to 1, from 1 to 0 all the time. And this is gonna be loop. So even if I run right now, let's run it. This is gonna be loop, so we have to keep visited unexpected while Q. Okay, so I just simply ident here. Let's make it beautiful and nice. So the thing is that it's gonna be loop. Do we have to create visited node? But we can pass node multiple times, right? Okay, yep, hip hop Q. Oh yeah, Q as well. Come on. Mean cost, he push expected to. Yes. So we have Q, and here we have our thing like this. First element of the list will be and now we have a loop. So we have to track visited. But the thing is that we allowed to pass certain nodes a couple times, right? But it's not meaningful, right? It's like, is there any cases that we have to visit node couple times? I don't think so. Okay, let's do visited. Visited will be false multiplied by n, and here if not adjacent node, or we can do even better, we can do set. Adjacent node in visited, and we add it to visited here, and adjacent node. Right? So we're not gonna have okay, this is something. So we are not getting any results, only -1 visited. If not adjusted, not being visited, we add. I think I have to add root not as visited as well, right? Set with 0. If time is more than max time, then continue. If node equal n-1, if for adjusting node in gnode that we have, so I would print g just to make sure that we are doing it correctly. I think we are, but to make sure. Okay, so 0 connected with 1 and 3, 1 connected with 0 and 2, 2 connected with 5 and 1. It's perfect. Oh, 3 connected 0, 4, 4 connected 3, 5. Okay. So times, let's print times. I don't understand what is wrong with it. Okay, times will be, for 0 will be 1. For 1 is 10. For 3 is 1. Why 3 is 10? Okay, this is something weird with times. max time is 30. Okay, there is something wrong with the time. 1 is, from 0 to 1 is 1, right? For 0 is 1 time. But it shouldn't be. It's like, yeah, okay, I'm out of time. There is definitely something wrong with time here, and I will have to work more and find out what is wrong with my code. But that's it for today. Thank you.